Hey guys, happy Tuesday. Welcome to another weekly training that we're doing with our internal team here at our dev agency. We have been working to put these out every Tuesday. We've been training our team every Tuesday, and now we're just starting to stream the call. So if you're interested in learning about how we work and how we build applications, this is a great thing to tune into. So we've been particularly focusing on how to take the shape up concept from 37 signals, how to take all the AI vibe coding and kind of put all that together in a way to have our team where we have a single person developing an application and working with clients, and how we just organize and run our agency. So today we actually have one of our team members, Jonata, who's been working with us, I think, a little bit over a year. And Jonata's located in Brazil and has been a phenomenal asset to our team. Just has fixed so many things in our previous Flutter Flow applications, and now helped us move out of Flutter Flow into a Flutter app where we can now use AI and Claude and everything to code. So I'm going to turn this over to him, and he's going to be doing an introduction to Flutter. So if this is the first time you're working on a Flutter app, especially if you're working on it with our team, this is something that would be required learning just to kind of get up to speed on how Flutter works and how it all connects. So I'm going to turn over to Jonata, and there you go. What's up?
Hey man, thank you, Bruce. Very happy to share a little bit of my experience. For this presentation, I prepared a kind of practical introduction to Flutter and Dart, and also we'll be touching a little bit of how we use it on Tribe Social Mobile. But the idea is that this presentation will lay the foundation for future talks as well, so we can go deeper. So this will be a really nice overview over the Flutter structure, the Flutter framework, and the main concepts that I think are important to understand in order to be able to create applications that perform better and that have a great user experience overall. So I'm looking at the chat here, so if anyone has any questions, you can also send on the chat. I'll be looking at it, and also feel free to jump at any time to ask questions. So let's start. So let's start with a very, I would say, like generic introduction of what's Flutter. So Flutter is a Google open source. And this part, it's open source. I think it's very interesting because it allows us to like move things around as we need and really dive deep into the code if we need to do something custom. But open source UI toolkit that enables developers to build natively compiled applications for mobile and web and desktop from a single code base. It's powered by Dart, and it streamlines development by eliminating, and I said like most of code duplication, because as we see, there's still some native coding necessary for some specific features, especially the ones that are very hardware dependent or OS dependent. So it's still needed to do some work on Swift or Kotlin if we are doing some very specific things. And also, Flutter was designed to have a native performance that's achieved through direct compilation, and I will show how this rendering system for Flutter works and why it's different from other hybrid platforms, hybrid frameworks. And I will showcase a little bit of the difference between web and mobile development for Flutter and how the performance-wise works for both platforms. So let's, and I added here on the web, on the end, that web version still has some rendering stuttering issues. Mobile is a lot better in terms of performance, but we'll look through this in details on the next slide. So really quick here, doing a kind of reality check for the cross-platform idea for Flutter. So the idea is that you write once and you run anywhere. And this promise does comes with a few exceptions, especially that developers need to tweak the platform-specific behaviors or accommodate or OS or hardware level integration separately. So there are tools that we need to use. For instance, if you are going to depend on the a lot of customization, a lot of work with camera or with the gyroscope from the phone, from these hardware specific things, there is a chance that you won't find a Flutter component or a pub, as we call the extra package we can add on top of the Flutter framework. You may not find this already done, like this integration in the hardware level. So you may need to write native code. But the interesting part is that Flutter is very open to it, and it allows for us to have like native bridge. So you can write your code in Kotlin, and also you can write in Swift, and you can use this code on your Flutter application, which is a very interesting ability that we have. So that's it in the hardware level integration. Also, Flutter web apps tend to have larger bundle size, which impacts initial load times and browser performance. And SEO remains a challenge because, as we'll see on the next slide, Flutter uses a very specific way of rendering the interface. We basically use painters to draw the interface, so we are not using the usual HTML or Material or Cupertino components provided by Apple, Google. So we kind of, the framework, Flutter frameworks, is drawing everything from zero, let's say, which is a challenge for having a proper SEO for these pages. And we also have some browsers compatibility issues, especially for advanced device features requiring fallback logic or native implementations. Flutter Web excels at internal tools, dashboards, complex UIs, and cross-device user experience, where SEO is less important. These are the ideal use cases for Flutter Web. And also, it's great for rapid prototyping and reducing the development cycle by reusing the logic across different platforms. And also, Flutter Web is doing a great job on the PWA side, on the PWA support side. So if you have a Flutter Web application that you'll be running only only as a PWA, it usually has a better performance than if you treat it as a normal web application. Also, I wanted to kind of bring a little bit of a comparison across other cross-platform frameworks. So as you can see here, the usage of Flutter is growing across the years, and Reactive Native is actually is slowing down. The growth is actually is slowing down for this platform, and the use is actually getting lower volume as the years passes. And I think a lot of this is because Flutter has a very interesting ability to in how it's generating, in how it's rendering the interface. So one last piece of information regarding this comparison, because I think like Reactive Native and Flutter are the main players when we talk about hybrid development right now. So one interesting data is that the Flutter repository has a little bit more stars than Reactive Native, showing how the Flutter community is still active. And one funny fact is that I've started working with Flutter, I believe, like 6 or 7 years ago, and since then, almost every year it comes around some form of news that Flutter is dying or Flutter is dead, and only for to continue living for the next year. So this is one thing we need to take with a grain of salt when looking at this type of hybrid platforms development. So moving forward, one very important piece of Flutter is how it works with rendering. So Flutter delivers a fast native-like apps by skipping the device's built-in UI components, the OAM widgets, and instead drawing everything itself. So it uses the Skia or Impeller in the newer version Flutter 3.29 forward. I think the default is Impeller rendering engine or Canvas Kit for the web to render directly on the device's GPU. So the OEM widgets in mobile development refer to the built-in UI components provided by the device operating system, such as buttons, sliders, lists, and text fields created by platforms like Android that has the material guidelines and the iOS with the Cupertino components. So Flutter doesn't use it directly. If you see the Flutter widget catalog that you'll see a little bit further on the presentation, you see that we have the material widgets and the Cupertino widgets, but they are being drawn from zero using these rendering systems instead of relying on converting the code to Swift or to Kotlin to use the material or Cupertino libraries. We draw it from zero. So these widgets use system level code and styles, ensuring the app looks and behaves in a way that matches the native experience of that device. And they are called native because they are maintained and rendered by the operating system, not by the app developer. Flutter skips all that and draws the interface directly. So this is very important to be aware because Flutter is very dependent on rendering the components, and this changes a lot on how we think about it in terms of performance of the system. And so in a lot of cases, we would be avoiding drawing things directly, but in Flutter click case, it's actually better. So sometimes if we need a very custom component, sometimes it's just better to just get a custom painter and draw it on the interface. And since we have this very optimized render, the ski or the impeller, it's usually very performance oriented to do this kind of drawings directly using the renderers. So now moving forward about the Flutter philosophy itself, you see that as we go over the next pages of this presentation, we will be diving deep into the very initial Flutter concepts that are necessary to build our knowledge blocks to be able to add more complex things on top. So first of all, the very basic thing about Flutter is that everything is a widget. So you'll hear it often if you read the documentation, if you watch a tutorial. Widgets are the building blocks of Flutter apps user interface, and each widget is an immutable declaration of a part of the user interface. So widgets are used to describe all aspects of a user interface, including physical aspects such as text, buttons, and even like paddings or centering something. You don't have like a parameter that you center. Instead, you have a widget that's called center, and you add in all the widgets that are added as child from this center widget, then will be centered. So it's a very hierarchical based composition, and each widget nests inside its parent and can receive context from the parent. This structure carries all the way up to the root widget, as we can see here. So this is this is basically the hello world from Flutter. So here, as you can see, we have a material app, which is a widget. So it's the basis where everything is built on top. It's the material app. And then you have a scaffold, which is basically a structure that allows you to have an app bar and to have a body that is the basis for building the rest of the application. And as you can see here, it's all is very like HTML like. We'll be nesting these components, and when they are uh, indented a little bit further, this means that this part is a child from this one. And if they are on the same line, as you can see here, this means that they are on the same level of hierarchy. I have an image below here that makes it easier for us to see. So this is the visual result from this code would be something like this. So you have a app bar here on the top. You have the hello world text that is right here, and you have a sized box. So even this sized box is a widget, which is basically a widget that has a specific space to add between components, and a button. And as you can see here on the right, we can see the hierarchy more easily. So we have the center and the column that's inside the center, because the column is centered, as you can see here. It's a child from the center widget. And then we have the text, sized box, and button, all of them as childs of the as children of the column, all on the same level. So moving to the next part, which is one of the core concepts of Flutter, is that we have a declarative UI. So basically, when you code with Flutter, you write what the UI should look like, rather than imperatively specifying draw steps. Flutter he draws automatically on when data changes, similar to React. So, for instance, if we look at Swift, now Swift is doing has a little bit more a bit more of reactive touches to it, so it's a little bit more declarative, especially with the Swift UI. But on the early days of Swift, we had a structure very similar to this imperative style. So imagine that you want to turn this view into this view. So we have a yellow background with two components. In the imperative style, we would have to do something like, let's take the B view and set the color to red. Let's clear all its children, and let's create the C3 view and add as a child for the B view. So this would be the process in the imperative style to kind of move this screen on the left to the state on the right. It's the same screen, different state. On the declarative style, this is a little bit different. We just return a view B with the color, the child, and the information that we have as its own component, as its own widget. So here we have a small image to make it easier to understand. So basically, in the declarative style, you describe the UI structure and you return a composite widget. So it's a widget composed of other widgets. And in the imperative, you have a mutable objective state, and you call methods in sequence in order to kind of update this object. Okay. And also, please just jump on if you have any questions. If I'm going too fast, I can slow down and go back to any of the items. Awesome. So the next big thing and I really love this this little formula right here, because it basically says that the UI is always a function of the current state. So that's how you think about the interface on Flutter. It's a function of the state that we have. So when the state of your app changes, for example, the user flips a switch in the settings screen, then you change the state, and that triggers a redraw of the user interface. And here is the power of the Flutter handler. Since it's very fast and very optimized, the user never notices or almost never notices this redraw. So you can be redrawing all the screen to change just one component, and sometimes the user won't even notice if this is done right. The user, you can rebuild the whole screen, and the user will only see that, oh, that little component, that little button changed the state, but behind the scenes you could be rebuilding all the screen. So there is no way of changing the UI itself, like widget set text. You change the state and the UI rebuilds from scratch. So that's how we think in terms of building interfaces, and the main, let's say, philosophy behind the Flutter structure. It's the reactive model, it's the declarative UI, and it's the everything is a widget. So it's these three basis concepts that serves as the foundation for us to lay the rest of the interface and the rest of the structure of the framework on top of the three main core concepts. So let's move further. Now diving a little bit deeper into the widget fundamentals itself. Like I said, everything is a widget inside Flutter, but we have mainly two types of widgets: the stateless widgets and the stateful widgets. Let's start with the stateless, which is the most used generally. So stateless widgets are used when the UI doesn't depend on dynamic data. So widgets that have no mutable state, they have no class properties that change over time, they subclass the stateless widget. So they declare themselves by extending the stateless widget. Like on this example below, we are creating a class that's called, in this example, it's nice to mention, it's actually, both examples are from our tribe app. And in this specific case, we are looking at the chat feature, that we have. When we draw the interface and we say, hey, this is a text message, and this is the text that needs to be inside this bubble of text inside the chat, we won't be changing it anymore. So that's why the text message itself is a stateless widget. Once we say, hey, the user said hi, and they send the message, there's no going back. They can delete it, but they will be removing, they won't be updating the content of that text message. So as you can see here, also just to mention, many built-in widgets are stateless, like padding, text, and icons, things that don't change very frequently. And when you create your own widgets, you create stateless widgets most of the time. So here on the left, we have this small example for the text message class that extends the stateless widget and only has the text. If it's a reply to someone, the text color that should be used for this bubble, and if it's on the mobile view or not. And that's all we need for building this component. And since it's not dependent on dynamic data, then it can be a stateless widget, meaning it doesn't have a state. For the stateable widget, then it's our widgets that hold local state, like a counter or a toggle switch. For example, if a widget has a counter that increments whenever the user taps a button, then the value of the counter is the state for that widget. So it's, if something changes and the interface needs to change because that piece of data changed, then we are probably talking about a stateful widget. The widget needs to be rebuilt to update its part of the UI, and this widget then will subclass the stateful widget, and they store multiple states in a separated class. So this is very interesting. I'll show here below. We declare first the chat page, extending the stateful widget, and we define the structure for that chat page. So on this specific chat page, we have the group that this chat is inside. we have a reference to a conversation that contains all the data of message and users involved on this conversation. And we also have a static root name and a static root path that's using for the location of the app on the web page. And we have the chat page state, and it extends a state, and as you can see here, it's a state for the chat page itself. So we only can do this extension if we declare the chat page as a stateful widget. If we try to do the same thing for a one that's like here on the left, it won't work because it won't have a state associated with it. So and we have like some cool abilities, like we have this override method for the init state, so we can decide what we'll do when we initiate the state for this widget that we are building. In this case, we create the model for it, and we'll talk more about the model on the next few slides, but basically the model is the data structure behind the widget. And we log a Firebase event, and we then move on with the initialization of the component. Okay. So just to sum things up, stateful widgets holds mutable states and rebuilds on state change. Stateless widget, it's immutable and there's no local state. So the stateless widget is not rebuilt when there's a change on the state of the page. So the stateless widget is static. Now, moving to a little bit of a more, let's say, the fun part, let's say, is the layout system itself, because I personally really like how Flutter deals with UI building, because it's very easy to read the UI components itself, and as we can see, very dense library of and very complete library of widgets that are already available on Flutter. As I said before, we have here two design systems: Cupertino, that's the Apple design system, and Material Components, the Google design system. And both of them, and that's very interesting because they look exactly like the iOS and the Material component, but they're actually being drawn by the render. So they use painters behind the scenes to draw the square, the add text, and make it feel and look like the components we have familiarity with, but they are not using the components behind the scenes. That can create some form of lagging. As you can see, for instance, all the Cupertino components that we have here are kind of old now that we have all these new iOS versions. So if you look at the iOS 26, for instance, we have a different design for a few of these components, but the Flutter library didn't catch up yet because we need to kind of redraw everything from zero. But if you, as a Flutter developer, really wants to have the look and feel of iOS 26, for instance, then you can basically create this component yourself using custom painters, which is basically what these components are using behind the scenes to design and to draw the components on the interface. So let me go back to the presentation. So here are the main components: row and column, stacks for putting things on top of each other using the z-axis. Row and column are pretty self-explanatory. Container, it's a container. Padding, it's the spacing. So This is a very interesting thing about Flutter. When you want to add space, you literally add a widget that's called padding, and then you inform if it's going to be a top padding, if it's going to be a left, or if it's going to be a top, left, right, and bottom. So it's a widget as everything else we have. Just like the flexible and the expanded widget. For instance, if you place something inside the expanded widget, it will take all the available space. And this it's a kind of different way of looking of things, because on some other cases this would be like a property of the component. So you have like a column, and then you set that that column has the expanded property. In Flutter, you'll be declaring the expanded widget, and you'll be adding a column as a child for that expanded widget, and then the column will take all the available space on the screen for that component. Now we'll be moving from the Flutter framework itself to the Dart, which is the language that Flutter uses. And I will not like spend a lot of time on this topic for now. I just wanted to kind of give the three things that I think are useful here. So basically, Dart language is strongly typed with inference, which is a very interesting thing. So we can do like something like final data and pass a string, and then from now on, since you declared as final, the data is expected to be a string. And if you try to parse it to something else, it can cause a error. We also have null safety built-in, so variables are non-nullable by default. So if you declare a string name, the Flutter framework, the Dart language actually expects for it to not be null, unless you explicitly say that that string can be null. So this prevents null reference and errors that compile time. Finally, the soundness. So Dart's type system, like the type systems for Java or C Sharp, is sound. So it enforces that soundness by using a combination of static checking, compile time errors, and runtime checks. For example, if we assign a string to a int, it's a compile error. So if you declare like string a equals to 1, we'll get a compile error. We won't be able to build the project. But if we try to cast an object to a string using a as a string, but we are trying to cast a object that is a double, for instance, then it will fail at the runtime, throwing an error that you can't do that casting. And one useful thing here is that you can do a nullable casting. So you can try to cast at something, and if it fails, it will be null, and you can check for it, and then you can treat this error according to prevent failing it on runtime. Now, regarding the asynchronous management on Dart, we basically have like two keywords that handle all asynchronous programming here. So it's the async and await keywords. So they provide declarative ways to define asynchronous functions and use the results. So basically, to define a async function, you need to add async before the function body, and the await keyword works only if you are declaring a async function. So this is very basic, but I think it's interesting to bring this up because this is something we'll be using a lot in basically, I think almost every page that you'll be building, there will be some form of asynchronous call that you need to be making, and you need to wait for stuff. So this is used a lot. So there's a simple example here that we are declaring a future. So we are declaring, hey, on the future, we will be receiving a string for this create order message. We declare it as a synchronous function, and we say, hey, we need to get the order variable, but to get it, we need to await for the fetch user order function to complete. And when we add a await inside async function, the return will only be called once the await is complete. So this return right here only will be called when we have the fetch user order response. On this case, the fetch user order is just a delayed return with a 2 seconds delay, but you can imagine as how this can be any form of API call or anything that we need to wait the response from. And then to call the function we just created, we just need to use the await as well. So this will be automatically handled by Flutter. So when we run the main, it will print the fetching user order instantaneously. And since this is on the await, it will wait on the 2 seconds and then it will print the your order is and the data, the larger latte that we are passing here on the fetch user order. So just to nail this down, the key terms we need to think about in asynchronous programming for Flutter is basically the async and await. You can use the async keyword before a function's body to mark it as asynchronous, and you can use the await keyword to get the completed result of an asynchronous expression. And the await keyword only works with the async function. Okay, so that's it regarding the
Hey, quick
asynchronous
question.
part.
I see Ira had a question like, is a future the same as as a promise?
Yeah, perfect analogy. It's exactly the same thing. And future type is always, yeah, exactly. If you declare a asynchronous function, you always need to have a future as a return for it. And you can define which type of future you'll be receiving. And this can be even a generic. So you can have like a generic future. So you don't need to specify what you'll be receiving. And you can have like custom classes here. For instance, if we have like a user record, we can receive a future that's a user record and that has all the data mapping to the name property, the age property, and all the user information that we may need. Let me take a look in the chat. Perfect. I think I covered it all. So moving forward, the state management part. So we basically have two kind of state management. We have the ephemeral state, meaning the state that UI related, or it's the local state, meaning things you can neatly contain in a single widget. So this is intentionally left as a vague definition from the documentation, and you'll see below, because you don't necessarily need to choose one over the other, and the line is not so clear cut. But some examples are the current page in a page view, the current progress of a complex animation, or the current selected tab in a bottom navigation bar. All are examples of ephemeral states. I think we won't be needing this on the next page of the app, or we don't need to keep this for the whole user session. So this is what we call the ephemeral state. The app state is basically everything that's not ephemeral. So it's things that you want to share across all the app. So if you want to keep between user sessions, we have like user preference, login info, notifications, the shopping cart in an e-commerce app, and the read or unread state of articles in a new apps, for instance. So this is what we call the app state. And for managing the app state, this more complex state, then your choice depends on the complex and the nature of your app and your team's previous experience in many other aspects. So we have basically three built-in approaches in Flutter, like three native approaches for Flutter in how we handle states. The first and probably the most we use it because it's also the simplest is the set state. So it's a the first time I was learning about Flutter, I was like, hey, this is funny because it's literally like a function that you call, and everything that you uh, use inside means that you are updating a state that you needs to rebuild the application. So uh, it only works with a stateful widget and with only a single stateful widget. This stateful widget can be like a whole page or even a set of pages that are built over time, but in the code, it will be declared as a single stateful widget. And that's the limitation of the set state also. You can share the state with other widgets, which can lead to duplicate logic if multiple widgets use the same data. So it's the best use case for it is for simple widget specific UI updates, and this directly tells the framework to rebuild the widget. So it's a kind of the hard code way of saying, hey, right now I need to rebuild this because I've increased the counter, and this will cause all the interface to rebuild for that specific stateful widget. So the set state is a function of the stateful widget. Now, getting a little bit more nuanced here, we have the value notifier and the inherited notifier. So these built-in Flutter APIs let you organize and share state and trigger UI rebuilds when it changes. So we have the value notifier for a single value and the change notifier for complex state. Both have listeners that you can subscribe to. So you can use a inherited notifier to allow child widgets to listen efficiently for change in a parent state. The scope for it is that you can share differently from the set state. You can share state across multiple widgets, not just locally. And the use cases for simple values, you use the value notifier. And for more complex use cases, then you have to use the change notifier, and these triggers are built in listeners that are the value listener builder. So one example here, as you can see, we are the same way we have a count here. We are trying to keep like, this is the example of a counter. So we have a value notifier that's an integer, that's the counter, and declare the initial state as 0. And then we instantiate a listenable builder that basically says, hey, the value I'm listing is the counter, and every time it's changed, I want to run this builder right here. This builder has the context, the value, the new value from that was received from the value notifier, and we have the child itself. On this case, we are returning a text widget with only the value that we are receiving. The advantage from this method is that the couples the state changes and UI updates, and it's useful for shared values and more dynamic scenarios rather than the basic set state. The limitation is that we have some kind of manual listener management, and it's not always ideal for deeply shared state, which is kind of resolved by the last guy on our list, which is the inherited widget and the inherited model. The inherited widget basically is a way to share, to provide shared data to child widgets with minimal boilerplate, avoiding manual data passing, what we call prop drilling. So child widgets use a static method to assess the shared state, and rebuilds are triggered only when needed. many, and this is very interesting. So uh, basically, we'll see below, we have a lot of community based options that the community has built for providers on how we can manage the states for more complex use cases. But most of them are using this inherited widget and inherited model as the basis to build their providers and to build their infrastructure upon. So the scope is app-wide and can be used in any subtree, and can share data with any descendant. So when you want to avoid passing data down to every construction, so every constructor, we can use this inherited widget, which makes the code cleaner. So you don't have to pass the kind of creating a lot of boilerplate by repeating that, hey, this widget has a name and its child inherits its name, and its child inherits its name, and so on. So instead of like having to pass to every constructor, we can use this inherited widget. So here we have a small example. So let's say you have a class called myState that extends the inherited widget with a count as a property and a callback that's called the increment. So we declare the state and we say we depend on the inherited widget of exact type, and we pass the state we are creating, where we assert that the value is not new, and we return the result. And here we override the update should notify. So when this on this line right here is where we are stating when we want the state, or actually when we want the widget to be rebuilt. So in this case, we only be notifying when the count value is different from the old count value. And for usage, we can just call the class we just created, passing the context of the application and calling the increment. This will update the count and will notify the inherited widgets once this is changed. The advantage is that it's cleaner, it's more scalable way of manage shared data, and many state management solutions like providers are built on top of it. Limitations: more boilerplate compared to basic options, and not as flexible for fine-grained state control unless paired with the notifiers. So here I have a small table to compare for make it easier to understand. So the method set state is for a single widget. It's for local and very simple ephemeral states. Updates the whole widget and doesn't have a sharing. It doesn't have the ability to share its state with other widgets. The value notifier, we can scope to multiple widgets. It's best for shared, simple, and complex use cases. The listener rebuilds the interface and allow us to share the state. Finally, the inherited. The scope is tree-wide because we can inherit it at any point of the tree. So we can use it for global, shared, and app state, and all the descendants will rebuild when the parent is updated. If the update returns as true, for this update should notify that we are overriding for the inherited widget. Okay. And to finish this part, there is no clear cut rule. So to be clear, you can use state. You could build the most complex application using only the set state to manage all the states of the app. In fact, the Flutter team actually does it in many of their examples, including the starter app we saw before. But we can decide that for our specific context or our particular app, the selected tab bar is actually not a ephemeral state. For instance, if we want to remember that the last tab the user selected in our application was the community tab, and the user closed the application, and when you open again we want to be on the community tab, then we probably can't rely only on the state and set state management for it. We need to make it into a app state management. So key takeaways: build one the class cross-platform power of Flutter. So you build once and you deploy everywhere, even if you have some performance issues on some places. I think in general the trade-off is usually worth it, especially because you cut a lot of costs by having just one code base that you can run on mobile, web, and desktop. This is very good for quick MVP and prototyping and getting a faster time to market. We have the widget first thinking, so everything is a widget. You can compose complex UIs from simple, reusable building blocks using the declarative syntax. We have access to the Dart modern features like strong typing, null safety, and elegant async await patterns that make your code safer and more maintainable. And we have scalable state management, meaning we can start with very simple things like the set state and then graduate to more complex things like the provider as we want. One thing I forgot to mention here is that we have, if you right now I'm showing inside the pub dev, which is basically the library for all pubs related to Flutter, which are the package that are built for from that are built that community builds to help other devs. So to the state management. So we have Flutter block, we have River pod, we have hooks, we have a lot of variations of blocks, and we can see, and as you can see, like there are ones that have like 3 million downloads, others have a little bit less, and it's really up to you to take a look into what you like, what you think it fits best to your project. My recommendation is to usually don't start by adding a external dependency. You can try to, oh, sorry, let me share my screen again. In a second, I think. Okay. So my suggestion will be to always start with the built-in option. So try to use set state, value notifier, or the inherited widget. If for some reason you think this is adding too much boilerplate or this is being too much of a pain to manage, then look into the pubs. Because if you start with using a provider, you probably won't understand why the provider is needed on first place. So it's good to have this it's, I think it's borrowed from React solution. I think it's borrowed from React. I don't think it's like a Flutter.
We may be losing him a little bit. I don't know if that's me. You guys can hear me. Okay, yeah, I think it's Jonata. This is awesome. I know we're coming up on like a couple more minutes. I'll give him a second to hop back in, but let me clear this. There we go. We'll wait for you to unfreeze. I thought it was you. Okay, this is great. If he comes back, we'll let him wrap it up. But this is good. We'll probably do some more deep dives like this. Oh, there's Jonata. You're back. We lost you for a minute. Maybe we lost you again.
You lost me?
Yeah.
Can you hear me?
Yeah.
Can you see my screen?
Do you have any final thoughts? Couple minutes. I know we have a couple minutes left. We may have to go to a part 2 next week.
Yeah, I was thinking about that because I still have some stuff to talk regarding like how we are applying this to Tribe itself. But I think we can kind of cut it from now, because actually the next slide it will be like the tribe architecture review. I'll just share a small spoiler right here. So it's basically, we'll be looking at the key directories, how the folders are structured, and how all these foundational concepts actually apply to tribe. But I think it's better for us to leave this for a
Yeah,
second
we'll
a
do
second
that
time.
in part 2. So like and subscribe if you want to see part 2. We'll be back here next week. But thanks, Jonata. That was great. If you guys have comments or questions, you can always drop them in the comments if you're watching the replay. And always, if you're interested in joining our team, there's always an application in the description. So thanks, Jonata. We'll be back for a part 2, and we'll hang out for a second with the team.